on page 431, we're going to put a box around this formula. This formula has shown up on some of the final exams. Again, you don't need to memorize it. You don't need to know what each of the things stand for, because you will get that formula and what they stand for when you do it on the exam. Okay, so they will tell you that FV is the future value. They will tell you that R is the dollars of the regular investment. And this is the one that is a little bit tricky. What does this mean if I is the interest rate per compounding period? So I is your rate divided by the number of compounding periods. So if your interest rate is 5% and it's monthly, then you would put in 0.05 over 12. And N is the total number of investments. So what do these questions look like? So first of all, if you were doing this question, they would give you the formula. So determine how many monthly investments of $200 would have to be made into an account that pays 6% annual interest, compounded monthly, for the future value to be $100,000. So on the exam, you would get this formula. So I'll just write it out again. 1 plus I to the n minus 1 square bracket here, all divided by I. And on the exam, they would explain what each of those things mean. So your job is to take the information in the question and be able to put it into the equation. So we want the future value to be $100,000. We're doing regular investments of $200. 1 plus the interest rate is 6%, so we change that to a decimal. Compounded monthly, so I is the number of, is the interest rate per compounding period. So that would be 0.06 divided by 12 to the n, which we don't know because we're asked to find how many monthly investments, minus 1, all divided by 0.06 divided by 12. So to begin with, this formula looks messy. We've got fractions inside of fractions. It looks a little bit messy. We want to solve for n. Where is n? It's in the exponent. Okay? But this exponent, I'm going to put a blue box around it. Can you see that that is the power? The n is the exponent only to what it's in the brackets. So as an algebraic way to making this question easier, what we're going to do is we're going to do algebra, the regular algebra, to isolate that power. We want to get that blue box all by itself on one side of the equation. Then using our log laws is going to be a lot easier. This is not the only way to do it, but it will make it the easiest for you. Unless you would prefer I show you the hardest possible way to solve this. I can do that. It may be really, really long and convoluted, but I sometimes like to make my job to say, hey, this is the easiest way for you to solve it. And that would be if we can get that by itself. So right now, we're dividing by 0.06 divided by 12. If I wanted to get rid of this, I would have to multiply both sides by 0.06. Does that make sense? Because you're dividing by 0.06 divided by 12. If you multiply both sides by that, that would make your life a little bit easier. So I take my calculator out. I do 100,000 multiplied by 0.06 divided by 12. Luckily, it stayed a nice number, and now we have 500 equals 200 square bracket 1 plus 0.06 divided by 12 to the n minus 1, square bracket. Again, I haven't got the power by itself yet. What could I do next to simplify the right-hand side? Divide both sides by 200. So dividing both sides by 200, that will, 500 divided by 200 reduces to 5 over 2, or even better, type it into your calculator and get 2.5. And then on this side, and I want you to notice that once I divide by 200, do I need the square brackets anymore? No. So I'm going to erase them. We've almost got the power by itself. How could I get the power by itself? Right? I just need to add 1 to both sides. And now the power is by itself. Now it's going to be easy to use your log laws. So I want to solve for an exponent. I've got a power by itself. I can take the log of both sides. And when I take the log of something that has a power, that power can come out in front. And now to get n by itself, log of 3.5 divided by log of 1 plus 0.06 divided by 12. 251.1 payments. Now, you probably can't make a 0.1 of a payment. How many monthly investments would it be for the value to be 100,000? Well, 251 payments wouldn't quite be enough. So even though rounding-wise, like if you were asked to round that number, you'd round down to 251, right? Because it's closer to 251. But in this situation, $251 isn't enough. You would have to make that next payment. $252 payments in order for it to be enough. It's like if you were painting a wall and you figured out you needed 1.1 cans of paint. Well, then 1 can of paint won't be enough. You have to buy 2. You can't round down in those situations. So some things need to be done in whole units. This would be one of them. And so you would need 252 payments. How many years is that? How often are they making payments? How often are things happening? Monthly investments. Just over 20 years. So if you started right now, if you've got a job and you can afford to put $200 away a month from your job, 20 years from now, you go to that account, you could have $100,000. That'd be pretty exciting. I kind of wish I did that 20 years ago. Right? But I didn't. So I go to that account and it's got $0. Oh well. Right? But had you started it way back when, could have had a lot of money. But it is also very hard to find 6% interest these days. questions that you're going to try right now, 3 and 6.